folks, how we doing? Quick discussion of chapter 1.1. Please read chapter 1, important stuff. I will just quickly go over some of the terms. So please make sure you read and do all the homework. So it starts out, I'm just sort of flipping through the pages in order. Whenever I see a bold word, I'll talk about it. So they say statistics is the science of collecting, organizing, summarizing, and analyzing data. So some people argue whether statistics is a science or an art or somewhere in between there. Remember when we were talking about outliers? Sometimes if a number doesn't belong, we kind of just get rid of it. So there is a little bit of art to statistics, and you can make graphs a little bit misleading if you choose. We also discussed the mean, median, and the mode. Those are all technically averages. So which one you want to use can sort of persuade people because the numbers would be different. So we can make the average be either higher or lower depending on our argument. So if ever you see the word average, just make sure you ask or look into whether they're talking about the mean, median, or mode. Okay, so I'll do a little bit of drawing. So let's say there's a population of interest. Population of interest. Let's say we're talking about students at our college. I don't know, 20,000, 30,000 of them. Can't talk to everyone. So if we can't talk to the entire population, we take a subset of the population. So we would take a sample. And so when we take a sample, so if we take a sample and we were to describe that sample numerically, we would get statistics. So statistics has many meanings, but one meaning is statistics are numerical descriptions of a sample. So some statistics we've learned already, X bar, right? That's called the sample mean. And we talked about the sample standard deviation S. That's the standard deviation of the sample. So these are all statistics. They are numerical descriptions of our sample. And we can, talk about, those are the two popular ones. We'll leave it at that. Okay, so this is our sample mean is X bar, and S is our sample standard deviation. Now, if we were able to actually talk to every single person in the population, that's impossible, but let's pretend we magically could, then if we were able to do that, our population, we could figure out the mean of the population. That would be the mu. So remember we talked about the population mean before. So this is the population mean when we were talking about bell curves, population mean. And then if we were able to talk to everyone in the population, we could get a standard deviation of the population. So that would be sigma. That would be our population standard deviation. Okay. So things that describe a population are called parameters. Parameters. That's ugly. Let me put it up here maybe. It's one word. Parameters. Okay, so I think I'm gonna have to break up these videos into a bunch of little videos just in case anything goes wrong. We're already almost 5 minutes into this. Okay, so a population starts with the letter P, is described by parameters, starts with the letter P. A subset of the population is a sample. Sample starts with the letter S. Samples are described by statistics, starts with the letter S. Statistics are things like X bar and S. the mean of the sample and the standard deviation of the sample. Parameters, which describe the population, two examples would be the mean of the population, mu, population mean, or the standard deviation of the population, sigma, population standard deviation. So the whole idea, where we're heading with this class is we're curious about the whole population, but we can't talk to everybody, right? We can't talk to all the students at our college, so we just talk to a small sample. Hopefully the sample is representative of the whole population. I want the sample to not be biased. So if it's not biased, that means it would represent the population rather well. So the whole game is based upon my sample. I want to infer things. I want to infer things about the population based upon the sample. So tell me if this makes sense. Let's say we're trying to figure out the average height of a student at our college. If we were to take a nice representative sample, we could get an X bar. And tell me if this would make sense. Here's the big idea of the class. If this is a good unbiased sample and we were to get a mean height from that sample, it would probably be a pretty good approximation to the actual mean height of students at the whole school, the total population. So X bar is a good approximation of mu. And similarly, S is a good approximation of sigma. So the whole game we're playing is we can't talk to everybody, so we take a sample. And then based upon that sample, I want to say things about the larger population. So I want to make inferences about the population based upon the sample. So this whole game that we're going to be playing pretty soon is called inferential, making inferences, inferential statistics. Again, you see the word statistics. Statistics has a lot of meaning. So this whole game of making inferences about the population based upon the sample, that's called inferential statistics. This whole course is called statistics. And also statistics are numerical descriptions of a sample. Whew, a lot going on here. Okay. And we'll pause it there and continue with the next video.